Hello everyone, I'm very happy to see all of you guys again here and welcome back again to this Python programming series. In previous tutorial we learned about constructor in Python, like what is constructor in Python, why constructor is so important, how to create constructor in Python and so on. If you didn't watch previous video, please watch it. You can find link in I button or you can find link in description below. You can also bookmark the Python tutorial playlist and subscribe to this channel, so you don't miss any future video. In today's video, we will continue our Python tutorial series and we will discuss destructors in Python. If you're new to programming or just curious about this concept, you're in the right place. By the end of this video, you'll have a solid understanding of what is destructors in Python, why destructors is so important in Python, and how to use destructors in your Python projects. So, if you're ready, let's start today's topics. Alright, let's start with what is destructor in Python. In object-oriented programming, a destructor is called when an object is deleted or destroyed. Destructor is used to perform the cleanup activity before destroying the object, such as closing database connections or file handle. Python has a garbage collector that handles memory management automatically. For example, it cleans up the memory when an object goes out of scope. But it's not just memory that has to be freed when an object is destroyed. We must release or close the other resources object we're using, such as open files, database connections, cleaning up the buffer or cache. To perform all those cleanup tasks we use destructor in Python. The destructor is the reverse of the constructor. The constructor is used to initialize objects, while the destructor is used to delete or destroy the object that releases the resource occupied by the object. In Python, destructor is not called manually but completely automatic. Destructor gets called in the following two cases. 1. When an object goes out of scope, or 2. The reference counter of the object reaches 0. In Python, the special method __del _ is used to define a destructor. For example, when we execute del object _name, destructor gets called automatically and the object gets garbage collected. This is the how constructors and destructors works in Python object-oriented programming. Creating destructor using the __del method. The magic method __del _ is used as the destructor in Python. The __del _ method will be implicitly invoked when all references to the object have been deleted, i.e., is when an object is eligible for the garbage collector. This method is automatically called by Python when the instance is about to be destroyed. It is also called a finalizer or, improperly, a destructor. This is the syntax of destructor declaration in Python, where def is the keyword that used to define a method. __del _ method is a reserved method. This method gets called as soon as all references to the object have been deleted. And self is the first argument. Self refers to the current object. Let's see how to create a destructor in Python with a simple example. In this example, we'll create a class student with a destructor. And we'll see how to implement a destructor and how destructor gets executed when we delete the object. This is the example, how you can implement destructor in your Python class. In this example we have created an object of class student, and after calling show method, we're deleting object using del keyword. Once object s1 get deleted __del _ method get called automatically. Now, let's run this Python file to see the expected result. Open your command prompt, and type python space 20 _1 _2.py, then press enter, as you can see on the screen, once object created constructor get called and print the value which are inside constructor, and after delete the object __del__ method get called and print the value which are inside destructor. As you can see in the output, the __del__ method get called automatically when we deleted the object reference using del s1. In this code, we created one object. The s1 is the reference variable that is pointing to the newly created object. The destructor has called when the reference to the object is deleted or the reference count for the object becomes 0. Important points to remember about destructor. 1. The __del__ method is called for any object when the reference count for that object becomes 0. 2. The reference count for that object becomes 0 when the application ends, or we delete all references manually using the del keyword. 3. The destructor will not invoke when we delete object reference. It will only invoke when all references to the objects get deleted. This is the graphical representation of how destructor works in Python. Let's understand the all points using the example. First, create object of a student class using s1 equals student, Python. Next, create a new object reference s2 by assigning s1 to s2 using s2 equals s1. Now, both reference variables s1 and s2 point to the same object. Next, we deleted reference s1. Next, we have added 5 seconds of sleep to the main thread to understand that destructors only invoke when all references to the objects get deleted. As you can see in the output, destructors only invoked when all references to the objects get deleted. Also, the destructor is executed when the code, application, ends and the object is available for the garbage collector. Example, we didn't delete object reference s2 manually using del s2. Cases when destructor doesn't work correctly. The __del__ is not a perfect solution to clean up a Python object when it is no longer required. In Python, the destructor behaves weirdly and doesn't execute in the following 2 cases. 1. Circular referencing when 2 objects refer to each other. 2. Exception occurred in __init__ method. Circular referencing. The __del__ doesn't work correctly in the case of circular referencing. In circular referencing occurs when 2 objects refer to each other. When both objects go out of scope, Python doesn't know which object to destroy first. So, to avoid any errors, it doesn't destroy any of them. In short, it means that the garbage collector does not know the order in which the object should be destroyed, so it doesn't delete them from memory. Ideally, the destructor must execute when an object goes out of scope, or its reference count reaches 0. But the objects involved in this circular reference will remain stored in the memory as long as the application will run. In this example, ideally, both vehicle and car objects must be destroyed by the garbage collector after they go out of scope. Still, because of the circular reference, they remain in memory. Summary and quick recap. In object-oriented programming, a destructor is called when an object is deleted or destroyed. Destructor is used to perform the cleanup activity before destroying the object, such as closing database connections or file handle. In Python we use __del__ method to perform cleanup task before deleting the object. The destructor will not invoke when we delete object reference. It will only invoke when all references to the objects get deleted. That's all for this video. We will discuss more about object-oriented programming in upcoming videos with practical examples. And if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. If you found this video helpful, don't forget to subscribe, give it a thumbs up for more content, and hit that notification bell. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.